Welcome to today's lecture on problem solving. So today what we're going to do is we're going to dive into some very basic word problems to see how we deconstruct those word problems and create our equations. So the first thing that you need to know is that you will be following along in your lecture notes. This is section 2.4, an introduction to problem solving. This is part of the Module 1 handouts. The reason I'm not writing my problems on the board today is because, as you can see, they are all word problems. And so it would help you to have this document in front of you as you watch the video. That way you can see the words themselves as well as what we're doing here in the video. Okay, with that in mind, let's get started. So the first problem that we have says that twice the sum of -2 and a number is the same as the number decreased by 1/2. Find the number. Now, whenever I speak to my students, either in person, over video, Zoom, whatever it happens to be, and they come up with a question like, hey, how do I tackle this word problem? The first thing I always recommend is read it, then read it again. Let that word problem hit you in the face like a baseball bat. Of course, disclaimer, because this is now being recorded, don't get hit in the face by a baseball bat. Just saying. But that being said, what you want to do is have that same kind of effect. You want to be able to read it and get the initial anxiety of reading a math word problem out of the way. The next thing you want to do when you're rereading this problem for the second time is start to dissect that problem. See what information you can pull out. Now, there's some key words here. Typically, you can identify those very quickly. So let's jump through this problem and see this process. It says twice the sum of -2 and a number is the same as, wait a minute, is the same as is like a breaking point. It's an equation at this point. So let's look at that first part. Twice the sum of -2 and a number. Interesting. So twice the sum. So I have 2 times the sum of something, right? And it says twice the sum of -2 and a number. Don't know what the number is? I'm going to use my favorite variable, x. Not necessarily my favorite variable, but we use it often and it's easy to reference. Is the same as, so twice the sum of -2 and a number is the same as. That's my equation. That's where I know I have an equal sign. Is the same as the number decreased by 1/2. Now, we didn't change the number, so it's still x. So it's the number, not another number. Very different in keywords. So we have is the same as the number decreased by 1/2. Very good. Now, as you're reading through this, you're deconstructing. It's very important to read the problem for a third time to find out what that problem is asking. So it says twice the sum of -2 and a number is the same as the number decreased by 1/2. Find the number. So what you need to do at this point is actually solve this problem. Find out what x happens to be. So let's go ahead and do this. I do see I have a fraction here. So we're going to go ahead and clear that fraction. My LCD in this problem is 2 because that's my only fraction. So I'm going to multiply this entire this entire equation by 2. And remember, this is all one product. So I'm only going to multiply it one time. So I have 2 times 2, which is 4, times my quantity of -2 plus x. 2 times x. 2 times 1/2 is just 1. You are clearing your fraction, so that's why it is just 1. It's just your numerator value there. Okay, now, very good. What we're going to do at this point is simplify. let's go through the process. You can distribute here, so that gives me a negative 8 plus 4x is equal to, nothing changed over here, that's 2x minus 1. At this point, go ahead and continue by simplifying, move those terms back and forth as needed. I am going to move my 2x to the left, so I'm going to subtract it on that side, and likewise I am going to add my 8. So 4x minus 2x, that gives me 2x. Negative 1 plus 8 is 7. Solve for x by dividing by 2, and I get x is 7/2. Now, because we are working with word problems, something very, very, very important is the interpretation of that word problem. Now, at this stage, we're working with very simple word problems, so that interpretation is very direct. As word problems become more complex, this skill actually becomes even more important. You have to reread the problem again. Just make sure you've gotten everything that problem is asking for. Otherwise, you might have missed something. So just one more time. Twice the sum of negative 2 and a number is the same as the number decreased by 1/2. Find the number. What is the question asking for? Finding the number. Did we do that? Absolutely. So our interpretation is done. Excellent. Let's try another problem. I will need board space, so let's go ahead and clear this board. Okay. So our next problem, making sure I'm staying in focus here. Our next problem says twice the difference of a number and 8 is equal to 3 times the sum of the number and 3. Find the number. Okay. Baseball bat. It got us. Second time we're reading, we're going to start dissecting this problem. Twice the difference of a number and 8 is equal to, I'm going to stop there. Twice the difference of something, right? So twice the difference of a number and 8 is equal to 3 times the sum of the number and 3. So 3 times the sum of the number and 3. Find the number. Okay, so we've read through our problem a couple times. We've got it deconstructed into an algebraic equation. And what we are going to now do is solve. I don't see any fractions, so this looks pretty straightforward. I have 2x minus 16 when I distribute here. I have 3x plus 9 over here. I'm going to just move my 2x over. Likewise, I'm going to move my 9 over. And so that gives me, on this side, negative 25. On this side, x. Let's reread our problem. Twice the difference of a number and 8 is equal to 3 times the sum of the number and 3. Find the number. We did that. Excellent. Let's try another one. Again, I need board space. Okay, making sure I'm on the right problem here. Our third problem says a 25-inch piece of steel is cut into 3 pieces so that the second piece is twice as long as the first piece and the third piece is 1 inch more than 5 times the length of the first piece. Find the lengths of the 3 pieces. There's a lot going on here. Baseball bat. All right, let's read it again. So we're talking about something physical now. It says a 25-inch piece of steel. It could be a box, it could be a piece of steel, it could be a pipe, whatever it happens to be, I tend to find that it helps me to draw it out. So this is my piece of steel. I know that the whole thing is 25 inches. There we go. Okay, so I know I have a 25-inch piece of steel. We cut this into 3 pieces. It didn't say equal pieces, so I'm just going to cut it. So I got 3 pieces right there. Not to scale. Always draw not to scale. Okay, so the second 25-inch piece of steel is cut into 3 pieces so that the second piece is twice as long as the first piece. Question, how long is the first piece? We don't know. So we do know that we can call that first piece X. That's our first piece. We don't know. That's a nice way of saying it. But we do know that the second piece is twice as long as the first. And we know that the third piece is 1 inch more than 5 times the length of the first piece. So 1 inch more than 5 times the length of the first piece. Excellent. Find the lengths of the pieces. Now you may be looking at this and saying, wait a minute, we don't have an equation. We just have pieces and their relative sizes because we don't know how big the first piece is. And you're absolutely right. So we have to build an equation here. Remember, this piece of steel that you had a fixed length at the very beginning. It was 25 inches. That means after we cut these pieces off, if we were to put them all back together end to end, we should have a 25-inch piece of steel. It's just broken up. So our equation comes from adding the 3 pieces, and I'm going to put parentheses on this one simply to show that it is a piece. You do not actually need the parentheses, but I'm showing first piece, second piece, and third piece. When you put all of these pieces together, we know that they are equal to 25 inches. And what that means for us is now we can go ahead and take this equation and solve for that first piece, find out what x happens to be. So let's do that. So I have x plus 2x is 3x plus 5x. I have 8x plus 1 is equal to 25. So I just combine my x's. Subtract your 1, I have 8x is equal to 24. Divide by 8, x will equal 3. Are we done? No. Remember, this is where I said the interpretation component is very important, especially as the problems become more complex. So what you need to do is reread it. So a 25-inch piece of steel is cut into 3 pieces so that the second piece is twice as long as the first piece, and the third piece is 1 inch more than 5 times the length of the first piece. Got that. Find the lengths of the pieces. Did we do that? We have x. So did we get all of the lengths? Well, no. We got the first piece. So we know the first piece is 3 inches. What is 2x? Well, if x is 3, it's technically 2 times 3, right? Or 6. And that's inches. I'll go ahead and put my units up here as well. That's inches. So my second piece is 6 inches. I always like to go back and add it to my diagram as well. It makes me feel more complete in my problem. It's not a necessary step. But this is your second piece. This is your first piece. Now we need our third piece. Our third piece is 5x plus 1. Remember, x is 3, so that's 5 times 3. That is a 3. I will rewrite that. Plus 1. 5 times 3 is 15, plus 1 is 16 inches, and that is your third piece. Very good. Now, you can confirm this. You should always be able to confirm things in mathematics because you should be able to work with what your solution is in the original problem. If I look at my three pieces, just to give you a quick visual, this is why I do this. I have 3 inches, I have 6 inches, that's 9, plus 16 does give me 25. So this is a very quick, easy visual whenever you get to draw those problems out. Of course, not every word problem can you draw out, but if you can, I suggest doing it. Okay, very good. Let's do another problem. That, of course, means I need more board space. Okay. Our fourth word problem for right now says the left and right page numbers of an open book are 2 consecutive integers whose sum is 469. Find the page numbers. Baseball bat. What are we talking about? We're talking about a book. It's open. So I can draw that. So here's my book. Again, beautiful artistry. Here's my book. It's open. They are consecutive pages. That's typically how a book would work. You wouldn't jump from page 1 to page 500 just by opening the book. So you have your book open. You have 2 consecutive integers whose sum is 469. Well, what does it mean to be a consecutive integer? What we're talking about is sequentially one number after another. So 1, 2, 3, 4, 5, so on and so forth. Those are all consecutive integers to one another. If you were talking about evens or odds, even consecutive numbers would be something like 2, 4, 6, so on and so forth. If I'm looking at odds, I'm talking about 1, 3, 5, so on and so forth. But I'm talking about a book. The book is going to go from even to odd, so on and so forth throughout the entire book. That's how page numbers work for us. And so what we're going to do is say that the first page is X. We don't know what page we started on. We just opened the book up. But we know the next page is X plus 1. It's the next page. But we do know that the sum of these integer values is 469. So let's reread it just one more time, make sure we're good. It says the left and right page numbers of an open book are 2 consecutive integers whose sum is 469. So we have X plus 1. Remember, this is page 2 right here. If it helps, you can put parentheses. And that's equal to 469. At this point, you can go ahead and start simplifying. So let's do that. So I have 2x plus 1 is equal to 469. 2x is equal to 468 once you subtract that 1. And then divide by 2, you get x is 234. Go back and reread it. Make sure you're getting everything at once. The question on this one is find the page numbers. Find the page numbers. So I do have x. That's my first page. My x plus 1 will be 235. So my 2 page numbers are page 234 and page 235. And again, you can write that up here. So I know this is 234. This is 235. Does it add up to 469? Yes. So you are done. Okay, let's try one more problem. Last one for this lecture. Okay, here we are. In an isosceles triangle, the measure of the third angle of the triangle is 30 degrees more than twice the measure of either of the other 2 angles. Find the measure of each angle of the triangle. Baseball bat. What are we talking about here? We're talking about a triangle. but we're talking about a special kind of triangle. So I'm going to go ahead and draw this out. Think back to your geometry days. An isosceles triangle means that you have two equal sides. So I'm going to say that this side and this side are equal. They're congruent. Now, what that means is that these angles here and here are also equal. And that's because they are opposite of those congruent sides. Now, a whole lot of geometry there, but go with it for just the moment. Go back to the word problem. It says, in an isosceles triangle, which we have just drawn, the measure of the third angle of the triangle is 30 degrees more than twice the measure of either of the other two angles. Now, the third angle is this little left out guy right here. I'm going to put 2 marks on him. This is our third angle. And we're going to put a little equation here. That's why I put this line. Now, it says the measure of the third angle of the triangle is 30 degrees more than twice the measure of either of the other two angles. Well, we don't know these measures, so they're both x. We know that the third angle is 30 degrees more than twice the measure of either of these two angles. Okay. Now, great. It says find the measure of each angle of the triangle. How do we do that? We don't have an equation just yet, but if you're looking at a triangle, the inside measure of the angles, the sum of all the angles of a triangle, is 180 degrees. And so, if I were to take my 2 angles here and my third angle, if I were to add all of them up, they should sum to 180 degrees. Now, with that information in mind, with our equation built, we can solve. So, I don't see any fractions or decimals, so I'm going to go ahead and combine my like terms. So that gives me 4x plus 30 is equal to 180. Subtract your 30 over. You have 4x is equal to 150. Divide by 4. If you need to use a calculator, that's perfectly fine. But as you divide by 4, you will come out to a decimal. You'll come out to 37.5 degrees. Now, let's go back. The question here is find the measure of each angle of the triangle. Did we do that? We have x, which is this angle. It's also this angle. So we have the measure of the first 2 angles. Okay, good. The next one, the third angle, is 30 plus 2x. So you just have to simply plug it in and solve. So I have 30 plus 2 times my 37.5. This is 75 plus 30 gives you 105 degrees. So those are your angles. This is your third angle. And these are the base measures for these 2 bottom angles. Okay, guys. Thank you for tuning in for section 2.4. I will cover section 2.5 in another lecture.